In this lecture, we are going to discuss about Cauchy's integral formula. First, we will see the statement of Cauchy's integral formula. Cauchy integral formula says that let f of z be analytic inside and on a closed simple curve C if A is any interior point to C, then integral over C f of z by z minus a dz equal to 2 pi I into f of a. This is the Cauchy integral formula. The generalized formula is a generalized formula is integral over c f of z by z minus a whole power n plus 1 dz equal to 2 pi I into f nth derivative of a by n factorial. So the difference between Cauchy integral formula and the generalized formula is, so here z minus a, but here z minus a whole power n plus 1. The power is the difference. Now we will solve the problems. Evaluate integral over c sin pi z square plus cos pi z square by z minus 1 into z minus 2 dz, where c is mod z equal to 3. It's a circle of radius 3. Now we will see the solution. Solution. In the formula, we have only one factor, but here we have two factors, so we should split this using partial fraction. Now consider 1 by z minus 1 into z minus 2. Now do the partial fraction, that is a by one factor plus b by another factor. So do the partial fraction. First take LCM and then simplify. Now what do we get? A into z minus 2 plus b into z minus 1 equal to 1. Means here if you take LCM, then what do we get? So a into z minus 2 plus b into z minus 1 by z minus 1 into z minus 2. So now compare these two, then you can get this equation. Now substitute the arbitrary value for a and b, z, then you get values of a and b. Now put z equal to 2, then first term vanish, then b equal to 1. Similarly put z equal to 1, then second term vanish. In the first term you get minus a equal to 1, so a equal to minus 1. Therefore the 1 by z minus 1 into z minus 2 can be written as 1 by minus 1 by z minus 1 plus 1 by z minus 2. Now the given integration can be splitted as I equal to integral over c sin pi z square plus cos pi z square by z minus 1 into z minus 2 dz can be split as two integrals, like minus integral, because a is minus 1. So sin pi z square plus cos pi z square by z minus 1 dz plus integral sin pi z square plus cos pi z square by z minus 1 z minus 2 dz. So now let f of z equal to sin pi z square plus cos pi z square, the numerator, because the integral formula says that integral over c f of z dz by z minus a. So for the first integral a is 1, and for the second integral a is 2. And so here itself you find f of 1 and f of 2. F of 1 equal to sin pi plus cos pi. Sin 0 is 0, so sin pi also 0. And similarly cos 0 is 1, so cos pi is minus 1. So you get minus 1. Similarly f of 2 equal to, what do we get here? If substitute z equal to 2, then cos for sin 2 square 4 pi plus cos 4 pi. You know, so this is 0, and then this is pi, and this is 2 pi. And then once again, if you go like this is 3 pi and then 4 pi. So 4 pi is cos 4 pi value is equivalent to cos 0 value. So cos 0 is 1, so cos 4 pi is 1. Similarly sin 0 is 0, so is equal to 1. Now the given integral value will become, which is equal to minus um, integral over c f of z dz by z minus a equal to 2 pi I into f of a. So here minus 2 pi I f of 1 plus 2 pi I f of 2. So you know already f of 1 value and f of 2 value, substitute here. So minus 2 pi I f of 1 is minus 1, f of 1 is minus 1, and f of 2 is 1, 2 pi I into 1. So further if we simplify, then you get 4 pi I. This is the value of the given integral. Thank you.